All right, so in this video, we are going to do another chapter 9 quiz, which is basically combining functions, and this is going to include 8 questions. So let's get into it. Question number 1 is a graphing question. It gives us f of x equals to sine x, and g of x equals to x, and then we need to draw the graph of y equals to f of x plus g of x. So in order to answer this question, we need to know what each individual graph looks like. I know that a sine function is just like this, and it repeats basically forever in both directions. And I know that a linear function is just like this, passes through 0, 0, and it's got a y-intercept of 0 as well, passes through the origin. So if I were to add these two functions and combine them, basically, we know that at the y-intercept, they're both 0. So the third graph is also going to have a y-intercept of 0. That's really important. Combination has a y-intercept of 0. And then the graph is just going to look like these two combined. So it's going to look like a sine wave that's kind of going upwards and downwards and like this continuously. And it's going to continue the same thing in the other direction as well. So that's kind of what the graph looks like. Continues forever in both directions. And basically the slope, you can think of this as a slope of 1 in there. That's what the graph of f of x plus g of x would look like. Let's go to the second question. We have f of x equals 1.4 to the power of x. This is an exponential function, and g of x equals to cos x. And we need to sketch the graph of f of x times g of x. Again, let's just draw the individual functions out. I know that this is exponential growth because this number is larger than 1, and exponential growth just looks like that and has an asymptote at y equals to 0. The y-intercept is 1. I know that cos x is like this, and it continues forever in both directions. Again, y-intercept is also 1. So if I multiply these two functions, the y-intercept of my third function would also be 1 because 1 times 1 is 1. So the y-intercept of this function is going to be 1. And then if I combine these functions, this is really, really flat and low. What's going to happen here is it's going to get really, really flat basically and hug the axis and get even closer and closer and keep alternating like that. On this side, the value gets really large. So these waves are going to get really, really large on this side. Larger one here, and then it keeps getting larger. And it'll eventually keep getting larger and larger because the y value here keeps getting larger, but this alternates at the same rate. So this is what a graph of the multiplication of these two functions would look like. Third question, we have f of x equals x squared minus 9 and g of x equals x squared minus 5x minus 6. And we need to determine the equations of the vertical asymptotes for f of x over g of x. So to find vertical asymptotes, we just put the first function over the second function. And let's factor both the top and the bottom. So the top would be difference of squares. And the bottom would be a simple trinomial, so man method, x minus 6, x plus 1. Now, if you cancel anything, you would cancel them. That would create a hole, but over here, we can't cancel anything. So we just look at the denominator for our vertical asymptotes. So in this case, our vertical asymptotes are going to be the solution of the denominator, which is x equals to 6 and x equals negative 1. Fourth question, very similar. We have two equations, f of x equals x squared minus 9 and g of x equals x squared minus 5x plus 6 this time. And we need to find the equation of the vertical asymptotes of f of x over g of x. So same idea over here. We want to start by just factoring. I'll write the top over the bottom first. And if I factor, that's x plus 3 times x minus 3 over x minus 3 times x minus 2. So I can cancel these out in this case. I'm just left with x plus 3, x minus 2. That would be a whole for that cancellation. So over here, I'm left with only a vertical asymptote of x equals 2. Fifth question, the zeros of a function of f of x are 3 and 4. So these are the x-intercepts, and the zeros of the second function, g of x, are 3 and 5. What are the zeros of the function of f of x over g of x? So for f of x, I can just write my function as x minus 3 times x minus 4. And for g of x, it's x minus 3 times x minus 5. These cancel to create a whole, which means that the only zero left, zeros are from the top, vertical asymptotes are from the bottom. So the only zero left is going to be x equals 4. Vertical asymptote would be at x equals to 5 for this one, and the whole would be at x equals to 3. Sixth question, the zeros of f of x are 3 and 4, and the zeros of g of x are 3 and 5, and we need to find the zeros of f of x times g of x. So if I wrote this as an equation, it's just x minus 3 times x minus 4 times x minus 3 times x minus 5, which is just x minus 3 squared times x minus 4 times x minus 5. So my zeros are just x equals to 3, x equals to 4, and x equals to 5. Seventh question. So the zeros appear on the graph. So the zeros of the function g of x in the equation y equals to f of x over g of x. What are the question basically asks, what do the zeros of the function appear on as a graph? Well, since g of x is in the denominator, remember our denominator is just wholes or vertical asymptotes. And last question, if f of x and g of x are odd, what is f of x times g of x? Is it going to be odd, even, or neither? Well, let's think about this logically. Let's make f of x equal to x. Let's make g of x equal to x cubed. These are two odd functions. If I multiply them together, I'll get x times x cubed, which is x to the power of 4, which is basically an even function. So if you multiply two odd functions, you will get an even function.